obtaining diisobutyl aluminum as a catalyst and protect the comonomer. Speaking about Young-Gon, so I'm Dr. Costa student at Professor Shiono Laboratory in Tokyo Institute of Technology. Generally speaking, polypropylene is being widely used in commercial utilization due to chemical and physical stability and low material cost. However, polypropylene show low compatibility with other materials because of nature. So from these reasons, the functionalization is useful for the high performance polymer material. The common method to produce functionalized polypropylene is a chemical modification of produced polymer and third polymerization method. And in the chemical modification of polypropylene is very difficult under the mild reactive condition. In many cases, the reactions involved in the side reactions such as the degradation and cross-linking during the modification reaction. In the catalytic polymerization method, is also purely active site of a catalyst is intolerant to functional group of the comonomer. This is just the disadvantage of this method. On the other hand, another method to produce the functionalized polypropylene is the polymerization of propane with alpha omega dienes by metallocene catalyst. Is the one of two double bonding is one of two double bonding is incorporated to the polypropylene main chain. And the remainder olefinic groups is maybe is applied for the another reactions. But however, the cyclic polymerization by the polymerization is prevents the introduction of high vinyl groups with keeping the original property of polypropylene. Additionally, is the linear osmotically is the substitute diene is investigated to produce the reactive polypropylene with pendant the vinylene groups. The new approach in the functionalization of polypropylene is direct polymerization with the boron-contained monomer. This method has focused on the stability of the boron components to the active site of the catalyst and versatility of functionalization. As described above, it is still difficult to produce well-defined functionalized polypropylene due to the simultaneous controls such as the copolymerizability and stereospecificity. From this point of view, we synthesize the 7 obtaining diisobutyl aluminum, the ODIBAs, the ODIBAs through the hydroalumination with the excess 1,7-octadiene and diisobutyl aluminum hydride at 60 degrees centigrade for 6 hours. After hydroalumination, the remaining non-reactants is stripped by evacuation. We expected the stereospecific metallocene catalyst can be alkylated by the ODIBA, so the active species of a catalyst maybe is formed by the anion complex. So during this activation process, the ODIVA is participating in the activation as a co-catalyst and can be incorporated to polypropylene main chain. So for the functionalization, the produced polymers to quench the oxygen and room temperature. For comparisons, some part of the produced polymers quenches the methanol. That we will discuss details later. The poster was the expected structure of the ODIVA is demonstrated here. So these tables they indicate the result of the reaction between the E617 octadiene and diisobutyl aluminum hydride. So the hydrolysis product is isobutane and 1,7 octadiene, and 1-octane and octane is identified with each detection time with the authentic samples. At 60 degrees centigrade, the 1-octane is previously produced at this condition. So at 80 degrees centigrade, the one of the binding groups the inserted to the isobutane. So from this data, the productivity of ODIVA is dependent on reactor temperature. In the chemical structure of the ODIVA is in the proton NMR. So binding and internal olefinic groups the assigned at 4.6 and to 4.9 and 5.6, 5.7 respectively. And additionally, in the carbon-13 NMR corresponding carbon resonance assigned here. This table shows the polymerization of propane with the isospecific metallocene catalyst combined with carbonyl borate. The activity with the aluminum concentration, low aluminum concentration in feed is dramatically decreased compared with the polypropane. So in the activities with the materials, the aluminum concentration is decreased with the increasing aluminum concentration. So the number average molecular weight is decreased in with increased aluminum concentration. It means the chain transfer to aluminum is occurs in this case. So in the thermal properties, the melting point and heat of fusion is increased in the aluminum concentration. It means we can explain this phenomenon according to the addition of ODIVA. And additionally, is the polymerization of propane by the stereospecific metallocene catalyst combine the same anionic complex. So activity is also decreased with addition of aluminum, but decreasement rate of activity is less than that for isospecific catalyst. Increasingly, the number of molecular weight did not change so much. So it means that in case of the stereospecific polymerization, chain transfer to aluminum didn't occur. So in the thermal properties, they show the same tendency with the isospecific polymerization. This figure shows the structure of the produced polymer, and A spectrum each is the peak is produced the polymer is quenched with the methanols, and the B each is B spectra in the figure of the polymer polymers quenched with the oxygen to obtain the hydroxylated polypropane. In A spectrum, so the characteristic methyl carbon is assigned to 12 ppm. So by quenching the methanol. So on the other hand, another peak is assigned like as shown here. So in the B spectrum, so the polypropane to quench the oxygen. So the hydroxyl carbon resonance is assigned in 61.5 to 62 ppm, and in the syntactic polymers, we can assign that peaks here. So from this data, so we know the produced ODIBA is chemically incorporated to polypropylene main chain, and the pendant aluminum groups converted to the hydroxyl groups. This table shows the hydroxyl contents of produced polymer. So the hydroxyl content increased with the increasing the aluminum content mole concentration in feed. So the conversion from the pendant aluminum to hydroxyl group is more than the 75%. So we considering the functionalization condition is a very reasonable value. This figure shows the relationship, the activity versus hydroxyl content in polymer. So they showed in the reverse up. I'm sorry. The 0.124 ODIBA in feed is showed and optimized the point. This figure also shows the relationship between activity of hydroxyl content in the stereospecific polymerization. This is our conclusion. So the activity is decreased with the addition of ODIBA. Is like this. The hydroxyl content is 0.8. I'm sorry. This is just another data. So melting point and thermal property is lower than that of polypropylene. Thank you very much.